Hi. In this video what I'm going to do is do a basic review of the predict command in Stata, which is something that we touched on in 622, but it bears reviewing. The predict command is used in post-estimation, meaning after we've used regression analysis to estimate coefficients for effects of x on y. We can use the predict command to get estimates of y hat, or predicted values of y, and also to get our residuals. Before you can run the predict command, you first have to run your model. So I'm just picking up where we left off in the interpreting bivariate regression video and just running the exact same effective population on GDP model. So having run that, we can do the predict command. So what we need to do is after typing the predict command, we need to specify a name for our predictions. The default for the predict command is to generate y hat, meaning the values along the line, the regression line for each value of x in the data that the model would predict, meaning what do the systematic elements in our model, the coefficient for population, and the constant term produce in terms of a prediction. That's what this command does. So what I've done is I've just named a new variable GDP08 underscore predict, and that will just be the y hats for GDP08. The option if e sample just means that I am avoiding making out of sample predictions. I only want to make predictions for GDP08 within the bounds of my data. Okay. We see that if we move down on the variable window, you see that we've produced a new variable GDP08. And we see that there are 14 missing values generated. That's no surprise. This means that there are 14 missing values for population 08. Because without population 08, without x, we can't generate a predicted y. We would just be left with the constant term. If we go to the data viewer and scroll all the way to the end, we can see that a new column's been added for GDP08 predict. And this, for every value of for every single observation, we have a y hat, a predicted y. Now, we could certainly go through and compare GDP08 predict with GDP08 and calculate for ourselves the residual, see what the difference between them was, but in fact, there's a much easier option also using the predict command. In this case, we just specify the option res. What that does is tell Stata that we want to generate the residual. So what Stata will do is just go through for each of those observations and do that addition or subtraction, subtracting from the actual value of GDP08 the predicted value. That's what the option res tells Stata to do. Remember that before the option we always put the comma. I've just named this new variable GDP08 resid. You could name it whatever helped you remember what it was for. Okay, and now we can see that GDP08 resid has been generated. If we go to the data viewer, we see it's been tacked on. And indeed, if we just went through and did the math, we would get the same result here, maybe with a rounding error, but Stata has done it for us. So, if we use the sum command and get the average residual, what should it equal? If you said 0, you were correct. That's a key part of our assumptions for linear regression, and it should always equal 0. Don't be alarmed that we have something other than 0 here. I mean, if you did the math, 1.43 raised to the negative 6 is an extremely small number, and all that is a rounding error in Stata. If you look at the data viewer, it only goes up to 4 decimal points. If we allowed Stata to go on for many more decimal points or ad infinitum, indeed, the residuals would add up to absolute 0. But at this point, for all intents and purposes, the average is simply, for all intents and purposes, it is 0. We can gain some more intuition through scatter plots. A scatter of y hat on the independent variable generates a perfect linear relationship. This shouldn't be a surprise because, in fact, the predicted values for GDPOA are those that lie on the regression line at the values for population in the data. So it should come as no surprise. So that's exactly what the prediction command is generating. It's generating y hat, which lies on the regression line. A key assumption in linear regression is that there is no systematic relationship between the residuals and the independent variable, that there is no covariance between the x and y and the error term. Now, there are certainly more formal methods for testing this assumption. A key way to gain some intuition on this is just to do a scatter plot of the residuals on the independent variable and see if there appears to be any relationship. Okay. What we should be seeing is something that looks entirely just like a blob or a mass that just suggests absolutely no linear or otherwise relationship between x and the residuals. However, this suggests that there might be something systematic going on. We see as x increases, for this group, the value of the residuals seems to increase, although there is another group for whom it seems to decrease. Now, why these two relationships are at odds, it's not exactly what we want to see. There's something that is suggesting that there's something in the error term that hasn't been included in the model that's correlated with x and also correlated with y. So this is what we discussed in 622 as omitted variable bias. And you could think theoretically about what a model that models the effect of population on GDP as a strictly bivariate relationship might be omitting. So this is a first step towards sort of post-estimation analysis and regression diagnostics and building your model and seeing what you might be missing and what kind of endogeneity you might need to address. Okay, that's it for now. Thank you.